Hey everyone, it's that math magician. On this video, we're going to start our introduction to inequalities. And hopefully at the end of this video, you'll have a good sense of the definitions on what inequalities are, and more importantly, how we can use them and solve them when they show up in algebra. So what I'd like to do is I'd like to just jump right into some definitions into what inequalities are. Inequalities are not equations. Know that equations have equal signs attached to them. Inequalities do not. They have other symbols. And I already have some of these symbols ready to go for you to look at. And you can kind of start to understand what it means to be an inequality. Now the first one we have, and you might be familiar with these, but I am going to recap them, is the less than symbol. Notice that it's facing in the right direction, and that reads from left to right that it's less than. Now if we put a bar underneath that, kind of simulating the equal sign, then that changes to less than or equal to. That's what the equal sign underneath means. If you ever see a bar there, it means less than or equal to. Now if we flip that the other way, and now it's opening up to the left side, that reads as greater than. And again, I could put a bar underneath that to show that that is greater than or equal to whatever expression we're looking at. Now, you are used to seeing equal signs. And let me zoom out for a second because I have a number line here ready to go to help with an example for what I want to show. You're used to seeing equal signs when we come across equations. For example, if I were to write the equation, let's see, x equals 4, thinking about that on a number line, if I had that number line here, let's say the number line went from 2 to 3 to 4 to 5 to 6 to 7 to 8. On that number line there, if x equals 4, we know that we're going to put a dot right there on 4, and that shows you that x equals 4. Now that's an equation. Again, we call that an equation because it has an equal sign. The word equation comes from that word equal. What we're dealing with over here are inequalities, things that aren't equal to. And that's what we're going to be focusing on as we introduce this concept to you. Now let me go ahead and paste another number line here so I can get ready for my next example. I'd say let's stick with the 4 there. I like dealing with that 4. But let's now say that I want to look at x is greater than or equal to 4. Notice that it's changed now. I'm going to go ahead and redraw that number line 2, 3, 4, 5, 6, 7, 8. And now we need to start to think about this as a this or a that. That symbol here is greater than or equal to. Let's take care of the equal to part. Remember, that bar underneath is really just part of the equal sign there. So that means that x can equal 4. So that means I do want to put my dot right back on here where 4 is, because x is greater than or equal to 4. Now the first part says that it's greater than. So I'm looking here at this number line, and now I need to start to think about which direction here represents x being greater than 4. Are we talking about this section here on the left side of that dot? Or are we thinking about the right side of that dot? And what you need to do as you look through this is you need to think about both sides of 4. Which numbers represent it being greater than 4? And I hope you can start to realize that the part that is going to be greater than 4 is this right side there. Right? We know that 5 is greater than 4, 6 is greater than 4, 7 is greater than 4, and we know that 2 and 3 are not greater than 4. So I can go ahead and for this number line, I can shade in, you can highlight it, you can darken it. I'm just going to darken it here. This number line shows the reader that you are talking about all the numbers that are equal or greater than 4. All right, hope that's starting to sink in for you. Let's go ahead and look at another example here. Let me go ahead and get another number line ready to go. Let me zoom back in here. All righty. Let's go ahead and actually I'll place it over here so we can kind of have all these lined up here. Let's go ahead and look at another example as we keep zooming out here. Let's see, zoom back in. All right, let's look at the example x is less than 4. you're noticing that we're all kind of dealing with 4 here. 4 is really the boundary point. The boundary point is telling you where the boundary is starting, kind of like the start or the stopping point for the boundary of this inequality. So we know that our boundary point is going to be here at 4. Let me go ahead and renumber this. 2, 3, 4, 5, 6, 7, 8. Again, we know we're dealing with 4 here. So I can start to go ahead and put a dot here at 4 to represent that. Now, it's talking about the numbers less than 4. Again, as you start to look at this, you want to think about, is it the numbers on the left-hand side or is it the numbers on the right-hand side? Which numbers are less than 4? And hopefully you can recognize that these numbers on the left side, 2 and 3, those are the numbers that are less than 4. So when I think about wanting to shade in a portion of the number line, I know that I want to darken the part on the left-hand side because those are the numbers less than 4. But I need to stop and I need to think about that inequality. Notice that there is no equal sign bar underneath it. There's no equal sign here. So x cannot equal 4. We just know that it's everything less than 4. So what that means in terms of this dot that I placed, right now, this dot here looks like it's including 4 because it's closed. When it's an equal sign, we want a closed dot. When there's no equal sign, it needs to become an open dot. And so I need to go ahead now and erase that dot, and in its place, I need to put an open dot there to represent that there is no equal sign there. Please take notice that this equal sign here means that we end up with a closed dot. There is no equal sign there, so it stays open. We're not including 4. 4 is the boundary point, but x can't equal 4. It's everything less than 4. Alrighty, let's go ahead and look at maybe one more example to make sure we really have this solidified. I'm going to go ahead and paste that number line in one more time. And let's go ahead and look at one more example. Let's say we'll look at the example, let's see. Let's do that y is greater than 15. So I'm going to go ahead and make a number line here. Let's see, I'll do 12, 13, 14, 15, 16, 17, and 18. Alrighty, so I have my number line there. I see that 15 is the boundary point. So I can go ahead and know that I'm going to have a dot there at 15. But oh, I did just notice that there is no equal sign here. This is not y is greater than or equal to 15. It's just that y is greater than 15. So that dot at 15 should not be closed. Because remember, closed dots only occur when there is an equal sign. There's no equal sign. That dot there needs to stay open. So I know I have an open dot there, and I'm interested in all the numbers that are greater than 15. So as I look here on the left, and I look here on the right, I notice that the numbers on the right are all the numbers that are greater than 15. So I can go ahead and erase those highlighting marks and know that I have to shade in the part on the right-hand side, and that right there represents that y is greater than 15. Please make sure you take notice of that. If there is an equal bar there, that dot will be closed. If there is no equal sign, then the dot will be open. It's that Math Magician, and I'll see you on the next video.